Relation, right? Okay? We always use the word correlation. What does it mean? Correlate, right? So two variables. Okay? We are referring to the relationship between two variables. Okay? Two things that are changing, right? With me so far? Okay. One of the things we discussed, okay, in the very first class was that correlation is not causation. Remember? Remember our discussion about high self-esteem and low self-esteem? What was our discussion? About self-esteem. Why do people discuss self-esteem so much in this country? Saying self-esteem is so important, high self-esteem is
correlated with success.
Exactly, a predictor of success. Basically, high self-esteem causes all good things. The accumulation of research shows what?
No, there's no correlation.
No. Correlation
yeah.
Correlation does exist, but causation is questionable. Remember? Because prisoners, right? Convicts tend to have quite high self-esteem. Does it make sense? When they take high self-esteem measures. Does it make sense? Okay. So this is what we mean by correlation. Okay, correlation is simply if one moves, okay, if one variable increases, the other one increases or decreases. Then the question is how strong the relationship is. Okay? That index is called correlation. With me so far? The relationship between x variable and y variable, right? Okay? So whether, as x increases, y increases, or as x increases, y decreases. With me so far? This is positive, this is negative, roughly speaking. And 0 is pretty much linear, right? With me so far? So, in the real world, it's just a dot, right? Data points, right? X and Y, right? And then correlation basically measures the strength of the relationship. If points were scattered too much, like that, then the correlation is lower. Does it make sense? Even though it's positive. But if data points are clustered like this, correlation is higher, like 0.8, 0.7, 0.9. Does it make sense? Then what about all data points were on the single line? That's correlation of 1, right? Because there is no error. Right? Do you understand what I'm talking about? The so-called error is how much deviation each data point has relative to a straight line, imaginary straight line. Does it make sense? So if error is big, then data points are scattered. Does it make sense? If errors were small, then data points were clustered around an imaginary straight line. Do you understand that? Okay? But if imaginary straight line is something like that, then correlation is 0. Because Because as x increases, y doesn't move, right? That's why the correlation is 0. That's what strength is all about. Okay? Strength is all about. Okay, so far? Okay? And then the first thing we have to discuss is something called the Pearson product moment correlation coefficient. I know the name is long. There was a statistician named Carl Pearson. Carl Pearson. Okay? Carl Pearson. Right? His first name is Carl, C-A-R-L, but he loved Karl Marx.
So he changed it to.
Exactly. That's the real story. He officially changed his name. Carl Pearson. I'm not kidding. K-A-R-L.
What year was this?
I think at the turn of the century.
Okay.
Carl Pearson. Yeah, a long time ago, of course. He was really good at mathematics, and he developed so many statistical techniques, including this one, Pearson product moment correlation coefficient. With me so far? And then last time we discussed chi-squared, right? And then did you notice Pearson chi-square in SPSS printout? Pearson chi-square. Yeah, this guy. So Pearson was actually, instrumental to the development of a null hypothesis testing. With me so far? So this is a big guy in statistics. Okay. Sir Francis Galton. This guy had an idea about correlation, but this guy wasn't good at math. So he asked him to figure out math, which he did. And then now we have Pearson product moment correlation coefficient. This guy was so fascinated with the relationship, okay, between height and some things. Part of which went to eugenics, of course. Exactly, eugenics. Nazi used it, right? So it was terrible. But the whole point is he was interested in, measuring people's, the length of arm and, stupid things. Not stupid, but lots of things, okay? And then bunch of data, right? It's like a big data. He had a big data. Okay, I don't know what to do. Right? So, Carl Pearson helped. That's the whole thing. Okay, as far as correlation is concerned, I want you guys to understand a couple of things, okay? Okay, number one. We are talking about the linear relationship. The linear relationship. Which means the closest imaginary line is straight line. Does it make sense? This is curvilinear. Does it make sense? This is curvilinear, okay? Pearson product moment correlation coefficient cannot measure it, okay? More precisely, if you apply the Pearson product moment correlation coefficient to this, the number is wrong, pretty much. With me so far? The number you get is not exactly what you're thinking about. Okay. By extension, Please understand this. I shouldn't say this is an assumption, but as a statistical condition, you have to make sure that you won't have outliers like this, because one outlier like that, okay, will significantly affect the correlation. Right? So conversely, the Pearson product moment correlation coefficient is extremely sensitive to an outlier. Does it make sense? An outlier. Okay? So in this case, under evaluation, right? So the correlation will become lower. Does it make sense? Only 1 point. Okay? Both must be continuous variables, right? Or at least, ordinal, meaning strongly agree to strongly disagree. Does it make sense? Or at least that level, okay? By saying continuous. With me so far? Okay. So, Pearson product moment correlation coefficient. Okay? Suppose that this is the result we get. Correlation is expressed by R. Okay? Lowercase r. With me so far? And then the number 28 is, degrees of freedom in the parentheses. And then 0.42 is the magnitude. Okay? Magnitude of a correlation. With me so far? And then p-value, you guys know that, right? And then 0.021, that's the significance. Okay? Calculated p-value, remember? And then in this case, two-variable test. So there are certain things you have to understand this. Number one, plus or minus is direction. Positive correlation, it's when as x increases, y increases. With me so far? That's called positive correlation. Negative correlation, as x increases, y decreases. That's negative, the first one. Second one, number, actual number, in this case 0.42. 0.42 is the degree of the linear relationship between two variables, ranging from -1 to +1. With me so far? Okay? So 1 is a perfect correlation. 0 means zero correlation, no correlation. Okay? And then I just put in very weak correlation, moderate correlation, and so on and so forth. Do you see that? This is basically a list of absolute judgment. Okay? Some researchers say, oh, we had moderate correlation, which means between 4 and 7. Does it make sense? That's a magnitude. Then there is something called strength. Okay? Strength. Strength is how much variance in y can be explained by x. Okay? Let me explain what it means. Alright? In this case, this is an imaginary line. With me so far? Okay? Variance means an error. Distance from a data point to an imaginary line for each x value. With me so far? Okay? This distance, okay, is pretty much the amount of the error we have. Okay, so if you add all errors, okay, okay, the accumulation of all errors is the variance. the amount of variance in Y, right? Then the question is, how much variance can be explained by X, right? With me so far? How much variance can be explained by X, right? So, it's called the coefficient of determination and calculated by simply squaring it. Please jot down. Simply squaring 0.42. Okay? Simply squaring plus 0.42. That's the amount of variance explained. Okay? The key term is this, the coefficient of determination. Again, the coefficient of determination refers to how much variance in Y can be explained by X, right? By simply squaring plus 0.42, right? So, which means how much percent? How much means percentage? Percent of variance can be explained. That's what it means, right? So, do you have a calculator? Okay, would you please input 0.42 and then square it? What did you get?
0.1764.
0.1764, right? So 17.64% of variance is explained by X. Again, let me repeat. 17.62% of variance in Y is explained by X.
Is it always that, like, R squared, the coefficient of determination?
Yes,
always
correct.
Explains X?
Exactly. By X. By X, right?
Yes.
Variance in Y is explained by X. Exactly.
Explained by X.
Explained by X. That's the key term. Explained by X. With me so far? Because we are referring to the relationship between X and Y, right? Okay? So, in other words, we are trying to explain variances in Y by X. Because remember, we assume that X is a presumed cause. Right? Although not necessarily actual cause in the real world. Please understand number 1, number 2, number 3. Okay? And number 4 is simple. Number of parentheses and degrees of freedom, n minus t. Right? Sample size minus t. That's the degrees of freedom. Okay. Weird thing about R, a weird thing about R is that, okay, p-value, right? Okay, p-value. P-value is actually based on the t distribution. There is no such thing as R distribution. Okay? Whenever you see, unfortunately, SPSS doesn't show you actual T score. It's unfortunate. It doesn't. It just gives you a p-value. But based on what? T distribution. T-test we discussed. Why is that? Okay, I don't know. It's based on the calculation. Okay? It's based on the formula, which is close to T distribution. Does it make sense? Depending on the degrees of freedom. But the whole point is, okay? Whole point is, p-value is based on the T distribution, T scores. Okay? Okay. So now let's go to the textbook. Okay? Page 280. Okay, so that's the relationship between quality of marriage and the quality of the parent-child relationship. Right? So that's the relationship we are looking at. Am I correct? Okay. Which one is the cause?
Quality of marriage.
Exactly. See, that's the thing about correlation. Okay? For the sake of this discussion, we are going to put, okay, quality of marriage into X. Okay? But here is a difficulty about correlation. Correlation is not causation. If parent-child relationship is bad, that will affect marriage.
That makes your marriage bad.
Yeah. The whole point I am making here is that causation is not correlation. It's really difficult. Okay? With me so far? Okay, now, let's see what it says. So, in this case, let's assume that we are looking for a correlation itself. Okay? Whether a correlation exists or not. Whichever direction. With me so far? If we don't care about the direction, which test should we use? One-tailed or two-tailed?
Two-tailed.
Exactly. Did you get that? If we don't care about the direction, which is bigger or positive or negative, we use two-tailed test. Remember that. If we care about the direction, then one-tailed test, whether positive or negative correlation. Do you understand that? Now, then let me write a set of hypotheses, okay? Okay, I apologize using so many Greek letters, but that's not my fault. I didn't invent that, okay? This is called rho in Greek letter, okay? This is called rho, standing for R. Does it make sense? So again and again, why do we use Greek letters? Because Greek letters refer to parameters. Parameters of an imaginary population. Remember that? Right? Greek letters always refer to population parameters. Population parameters of an imaginary population, from which we assume that we drew a sample. Does it make sense? So this is raw, okay? Okay, so the null hypothesis is zero correlation. With me so far, right? And then alternative hypothesis is not zero, right? This is two-tailed test. Then one-tailed test. Whether it's larger than zero or lower than zero. Does it make sense? So either one is one-tailed. With me so far? Okay. Having said that, I'd like someone to come up here.
How many people was that again?
30 students.
30
sorry, 30 people.
30 people.
So, okay, now Tabitha can enter the data. Can someone please double check the accuracy of data? The second one is parent-child. Okay. No.
All one word.
Just parent. Parent-child, one word. Okay, that's good. All right. Then case ID, label, case ID, quality of
Quality.
marriage,
Quality.
quality of marriage, and quality of
PC.
parent
Child.
child relationship. Okay, so quality of parent child relationship, right? Okay, good. All right, going back to data view. Let's first save it on the desktop. Correlation, Pearson. Yeah, save. Okay, very good. Okay, so this is Pearson correlation. Let's go back to data. Yeah. And then first go to analyze frequencies, and then quality of marriage, quality of parent-child relationship statistics, mean, median mode, skewness, kurtosis, and then all dispersion. Okay? Right? Then continue, and then chart, histogram. Okay? And then okay.
There you go.
Okay, there you go. This is a descriptive statistics, right? You can go down. Okay? So the distribution table is here. And then histogram. You know, roughly, yeah. Can you go up a little bit? Okay, so kind of roughly, you know, normal. You can see that, right? One of the things. I forgot to discuss is something called normality. Okay? Normal distribution. More precisely, bivariate normal distribution. Two variables together in a three-dimensional world. Right? In a three-dimensional world, two variables together. Okay? That's called bivariate normality. But anyway, that's a technical name. But that's a fourth assumption. Anyway, now let's go to analyze. Okay, Tabitha, there is a bunch of lists. Which one do you think we should go? Exactly. Excellent. Correlate. Then which one? Ooh, there are so many options. How many variables do we have?
Two bivariate.
Exactly, bivariate. Exactly. Very good. And then variables. You can just enter those two. Right? With me so far? Now, suppose that you have 10 variables, right? 10 variables, 10 such variables, right? What you can do is to enter all 10. And then SPSS will give you a huge table, a correlation matrix, 10 by 10 matrix, that will give you. Does it make sense? So my point is you don't have to do 2 by 2 repeatedly. You can just input all 10 or 20 variables, continuous variables. And then SPSS can simply calculate 10 by 10 or 20 by 20 correlation matrix to you. It's quick, right? Does it make sense? Okay. Now, we have only 2 variables. Now, do you see Pearson, Kendall, and Spearman, right? Okay, in this case, we are going to click on Pearson. Okay, Pearson, because we have continuous variables. Okay, continuous variables. So we are going to click on, Pearson, right? Mm-hmm. And then SPSS is strange. For correlations, SPSS gives us an option between 2-tailed and 1-tailed. Right? Look at that. 2-tailed or 1-tailed, right? Okay, the point is for t-tests, okay, SPSS doesn't give you an option between 1/3 and 2/3. But for correlations, they do. Don't blame me, okay? So, in this case, okay, 2, right? Let's click on, already clicked, okay? And flag significant correlation. And look at an option, okay? Look at an option. Okay, so in this case, exclude cases pairwise. So, yeah, that's the only thing. Continue. And then okay. In a matter of second, there you go. Okay, thank you so much. Appreciate it.
Yay.
With me so far? Okay, so as you can see, this is the magnitude, okay, of a correlation, and you don't see negative, right? Okay, so this is plus 0.437. With me so far? Oh, by the way, we have to verbalize, okay, each hypothesis. So, in this case, you can say no correlation exists between x and y, right? Does it make sense? Or there is no correlation between x and y. In this case, x is quality of marriage, y is quality of parent-child relationship. With me so far? Okay? Either way is okay. Okay? Do you understand that? Okay? No correlation exists between x and y. Okay, there is no correlation between x and y. Or there is correlation. There is a correlation between x and y. Does it make sense? Okay. This is how you verbalize it. Okay. Now we found this one, right? Because this we are testing two-tailed test, right? Two-tailed test. So, assuming that you guys verbalized this hypothesis, those hypotheses. 437. Oh, in this case, how many? 30, right? God. Sorry, 28, right? N minus 2 is the degrees of freedom, right? So plus 437. With me so far? That's the correlation. With me so far? Okay. And then t value. 0.016. 210. Right? 28. Yeah. 28 is the sample size is 30, right? Okay? And then the degrees of freedom is n minus 2. Right? So 30 minus 2 equals 28. With me so far? Good question. Okay? With me so far? Right? So, what would be our decision?
Question about the hypothesis.
Uh-huh.
So since the first one has an equal sign, does that mean their correlation does exist?
0.
No correlation exists?
Good question. It's a matter of significance, right? So, inferential statistics is testing whether a given correlation is far enough from 0. 95% of the times, right? 95% based on 95% confidence. Okay? Can we say, okay? Can we say that a given sample correlation is far enough from 0? Okay? That doesn't necessarily mean in the real world it's actually 0. Right? It might be 0 or 1. There is always 5% error. Remember? there is always a chance that we are making a mistake for 5%. Okay? Statistics is like this. Statistics is always against a point. Okay? A point, which is a criteria. And then the question is, a given sample statistic, whether a given sample statistic is mathematically far away from 0 or the standard or not, right? Based on 95% confidence. Does it make sense? Okay? So, when we fail to reject the null, okay, our decision is basically there is no correlation between X and Y based on 95% confidence. That doesn't mean our judgment is 100% correct. Remember? Every statistical decision we make comes with a possibility of error. Right? Did I answer your question?
Not kind of. I was asking in the way you write the hypothesis. So
Mhm.
like, since the top one doesn't have the slash and the not equal,
Mhm.
would the verbalization of the top one be correlation exists, or would it be no correlation?
There is no correlation.
There is no.
There is no correlation between X and Y.
Okay. And
Right.
then the other one will be there.
There is a correlation. Does it make sense?
Mhm.
Okay. Now, how would you say? Because the p-value is
Less.
smaller than
0.05.
0.05,
There is significance.
because p-value is less than 0.05, what are you going to do?
Look on the
Reject.
reject.
HO should be
Rejected.
rejected. Correct. Excellent. HO should be rejected. Therefore, there is sufficient evidence to conclude that
There's
there is a correlation between quality of
Yeah.
marriage.
It'd be a moderate correlation.
Yeah.
Yeah.
Very good. Moderate correlation. Right. Moderate positive correlation.
So then, would we say that there is a 43.7% percent of variance in the quality of the parent-child relationship?
Very good. Square it.
Square. Oh, yeah.
Square it. Exactly. 0.437. Please square it. Then we can calculate the variance.
19.09%.
19.
1909.
09. Okay, so 19.09% of variance in Y, which means the relationship between child and the parent is explained by the quality of exactly. Do you see that? Right? Very good. HO should be rejected. Therefore, there is sufficient evidence to conclude that, okay, a correlation exists between the quality of marriage and the quality of parent-child relationship. And then, as Hannah said, 19.09% of variance in the quality of parent-child relationship is explained by the quality of marriage. Exactly. Does it make sense? Okay, trick question. What if we are looking for this one? One-tailed test.
Divide by 2.
Exactly. Exactly. Huh?
Can you give an example of when we would use a one-tailed test? Or like what?
Very good, very good, very good. Let's assume that the quality of marriage is positively related to the quality of parent-child relationship. Then definitely we are talking about the positive correlation, not negative one. Am I correct?
So then that would be reflected.
Exactly,
for the hypothesis.
exactly. Hypothesis. Oh, sorry. H1 is positive. Exactly.
But if it just says there's a correlation, then it's two tails.
Exactly.
Or is there?
Exactly. Because we are not, in
We
this
don't
case,
know.
we are not
Right.
looking for difference. Oh, no. We are not talking about the direction,
Right.
positive or negative.
Right.
But in this scenario now, when we are saying that, okay, let's find out whether the quality of marriage is positively related to the quality of parent-child relationship. Okay? If we say that, okay? If we say that, then we are actually testing one-tailed test. Right? We are looking for this one. But of course, we are testing.
So when we are doing our analysis.
I am very clear. Oh,
Yeah,
in your analysis.
when
Yeah.
we're doing this, like, do you recommend that we start with a two-tailed to see if there is a correlation?
Excellent question. It depends on your theory.
Okay,
It depends on your theory. If your theory says positive relationship, then positive relationship. Right? If your theory is talking about negative relationship, then it should be negative.
okay.
Very good. Does it make sense? Your case, civic engagement.
Yeah,
Okay, so news subscription and the civic engagement, or let's say news engagement and civic engagement. Does it make sense? Then, if you assume that the news engagement leads to
civic engagement.
civic engagement,
Then I'm looking for a
then
positive.
positive, exactly. You don't have to test
Okay, I don't have to.
Two-tailed.
We're gonna start where
exactly.
we want to.
Exactly. Do you see that? Okay. Now, relating to that question, okay, as I kept telling you, one-tailed test has more statistical power, right? More statistical power, okay? If we were testing this one-tailed test, what's going to happen to this? You guys already said.
Divide by 2.
Divided by 2, so 0.008. Exactly, 0.008, right? Significance decreased, right? Which means that one-tailed tests have more power. That's why significance decreased, which means more significant. Does it make sense? Okay? So it's for science to progress, it's always better for us to aim for more statistical power, which means one-tailed test. If hypothesis is, if we can construct a hypothesis in the sense that we are talking about direction. Agenda setting is something like that, right? Public agenda influences, media agenda influences public agenda in a positive way, right? So they are looking for positive correlation, not the negative. Do you understand that? So they are actually doing one-tailed test rather than two-tailed test. With me so far? Okay. If we get 0.008, I hope so. Right? Do you see that? When we use one-tailed test, then significance is half of it. Remember? Right? That's why one-tailed test has more statistical power. Whether we use t-test or correlation, that's the same. With this so far.